My name is Xianguang Yang. The title of my speech is Optical Properties and Lasing Physics in Flexible Fibers Doped with Nanocrystals. First, I will thank you, Vebleo, give me this opportunity to share my work. And I am come from Institute of Nanophotonics, which is directly affiliated to Jinan University. And this is the logo of institute. We call it AIM because our research is not art. This logo, a dragon chasing sun, stands for Chinese scientists exploring photonics. The prime goal of our institute is the frontier of optics in cutting-edge applications. Okay, next. In 2006, Nature reported top 5 in physics. Nanowires and quantum dots are ranked number 2 and number 3, respectively. Nanowires can be used to create nano-sized laser, and quantum dots can be create new kinds of lasers. They are all related to photonics. How about the combination of nanowire and quantum dots? Internationally, guys from France created a quantum dot embedded into nanowire for single photon source. And another guys from Switzerland assembled multiple quantum dots into nanowire for quantum photonics. And then scientists from Japan realized room temperature lasing by assembling some quantum dots with equally spatial distributed quantum dots. Herein, this outstanding works motivate us to combine quantum dots in the nanowire. Herein, the colloidal quantum dots come into our vision. They were called the nanoscale rainbow. In Nature, reported the nanolight revolution is coming with application of colloidal quantum dots. In our group, we developed a physical drawing method by dissolving quantum dots into polymer. First, we can obtain the mixture with quantum dots and polymer and drop it on glass, where silicon fiber will be approached to this mixture and then emerging into seconds 1 or 5, and then drop it at a speed about 1.5 or 5 meters per second. Then a polymer nanowire containing quantum dots was observed. This is our strategy. Herein, we go to macroscopic characterizations. Figure A shows the SEM image as a fabricated nanowire. And figure B shows the TEM image. This is containing quantum dots, and this is without quantum dots. The EDS results shows that CDSE, ZNS were obtained from co-share quantum dots. This diameter of polymer nanowire is 300 nanometers, and the embedded quantum dots is diameter of 6 nanometer. Here we give the TEM characterization of experimentally used quantum dots. The histogram shows that the average diameter of quantum dots is about 6 nanometer. And in figure B, this is the optical properties. Here in blue line shows the absorption of quantum dots, and the red line shows the emission properties of quantum dots with FWHM of 36 nanometer. Here we go to the characterization of polymer nanowire doped with quantum dots. In figure A, the blue line shows the optical absorption property of polar aniline nanowire doped with quantum dots, where this red line is the transmission properties of pristine polymer nanowire. We can see it is optically transparent during the 350 to 700 nanometer wave band. Figure B shows the emission properties. This is the PL spectrum of polymer nanowire doped with quantum dots. Here in the inset shows the polymer nanowire was excited by incident blue light. You can see this scattered blue spot is the incident light scattering, and the quantum dots embedded in polymer nanowire was efficiently excited and emitting red line. Okay, herein we successfully demonstrated the strategy of nanowire combining with quantum dots. Then we use this strategy exploring the photonics on photon emission, photon transmission, and photon detection. Then we go to our specific content. First, photon emission technology. In this section, we obtained the fluorescence blinking of quantum dots. Quantum dots was improved by regulating emission via electromagnetic resonances. They can be the surface plasma resonance of gold nanoparticle, and also can be the magnetic dipole resonance of silicon nanoparticle. By combining the gain characteristics with the nanowire flexibility, the ruin-shaped microstructure was constructed to realize multi-mode lacing. You can see this is a peaks of lacing. For more information about this work, you can see our published papers. Next, we go to photon transmission technology. Herein, we use the transfer of propagated plasma from severe nanowire and photon energy of quantum dots realized by exciton transmission. This strategy is no momentum matching. It with energy transition from photon to exciton and to plasmas. The transmission energy efficiency is up to 32%. In addition, the self-absorption of nanocrystals in flexible fibers was improved by enhancing the fluorescence emission of quantum dots with localized plasma resonance. The surface plasma resonance is comes from the gold nanorod Herein, you can see figure A and figure B. In figure A, the A, B, C, D, and E positions with gold nanorods, and A1, B1, C1, D1, and E1 without gold nanostate. The PL efficiency was improved from percent of 11 to percent of 79. Also, we published the results in these journals. If you have interest, you can download them. After photon emission and photon transmission, we go to photon detection technology. This is very interesting. It is found that the combination of quantum dots and nanowire forms a rich organic and inorganic interfaces, and the efficient separation of electron-hole pairs generated by photon excitation at the interface provides a good possibility for optical detection. You can see we got UV and visible detectors. And this is the schematics. This is the IV curves. This shows the devices of SGM microscopy. These devices shows the diode characteristics. You can see for positive bias, it is connected, and for negative bias, it is interrupted. And for more information, you can see our journals published in these journals. Okay, this work also featured in cover of nanoscale. You can see when light irradiated into the nanowire will be excited, and the quantum dots will get photon generated pairs with opposite direction, and without the electrical division, the detector will sensitive the photo incident light. Also, we are invited for some journals, nanophotonics, for invited reviews. We summarized our works in this journal. In addition, we also published the book chapters. This is published by Intech Open in London, UK. The book name is Plasmonics, and our title is Localized and Propagated Surface Plasmas in Metal Nanoparticles and Nanowires. This is mainly about the surface plasmas in metallic nanowire, such as silver nanowire and gold nanowire, and such as the resonance of gold nanorod. Another job is hybrid optoelectronic materials for photon detection applications. This mainly reported two jobs of detectors. They are published in the book of Advances in Optoelectronic Materials, which is published by Springer Nature. However, we also realized some advances from University of Cambridge. The use of nanowire with gradiated color into spectrometers. Okay, we share our recent advances. We got a nanowire with red nanocrystals with the incidence of green light and the blue light, we can obtain the colorful emission at the nanoscale. This is under revision. About color emission and color routing, we also have some simulated results. It can deflect red, green, and blue lights in different pixels for improve the resolution of image sensing. We call it the full color nanorouter for high resolution images. This is the configurations and the optical efficiency for red RGB lights. Also, we have do some works by metal surface for holographies. You can see this metal lens can have holography for some birds. This is our job. Recently, we are organizing a featured topic research in frontiers in materials. We organizing the papers. Welcome to submission into this research topic, photon-sensitive materials and devices for nanophotonics, optoelectronics, and photon electrocatalysis. This is topical editors. It contains practice and some sheets from chemist, and this is me from Jinan University. In addition, we also organize an international conference on price instruments and optical engineering. We got keynote speakers, these peoples, and we are the committee. This is the program committees. They are come from international board. Welcome to this conference. Herein is about me in 2008 to 2012. We got optics BS from Sun Yat-sen University and optical engineering PhD from Sun Yat-sen University also, and Jinan University from assistant professor to associate professor. And this is our cover paper. We all focus on photon emission, transmission, and detection. Acknowledgement. We thank our long-term collaboration, Professor Lee, and international collaborator, Professor Dario and Professor Andrew. And this is my 3 graduate students. We also thank the grant. Okay, thanks for your attention and welcome to collaboration.